Hey everyone, welcome back. This video is going to cover version 2.0 of the ultra instinct prototype rover I've been developing. Um, since version 1.0 I made a few design changes, got rid of some sensors that I feel like I didn't need anymore, and working more towards the autonomous vehicle portion of this entire project. Let's just get right into it. Just a little recap for version 1.0. Here's what the overall design looked like for 1.0. You have the motor controller, the batteries, and all their sensors. You can go back into this playlist and look at the version 1.0 for more details on my thought process for everything, why everything is where it is, and how everything's powered in this playlist. So go check it out. I'll leave the link in the description. Um, but let's just move forward for version 2.0, and as you can see, it's much more streamlined, a lot less clutter in terms of wiring and extra sensors that I felt like I didn't need. Just to go over, we still have the motor controller over there, the lithium polymer batteries that are powering all 6 motors, 3 on both sides, and one of the things, overall design outlook is, the Pi is moved from the front of the rover to the back, and the breadboard that connects all the sensors together is moved from the center to the front, and that kind of helps with some of the center of mass issues of having with some wheels being skidding out of control. But moving on to the more major things, one of the biggest things I've changed was the power supply for the Pi. So before we were using a kind of cylindrical battery pack, very small, didn't have enough current output to thoroughly power the Pi over time, especially with all the sensors I'm using. So this battery pack I'm using from Anker is my personal battery pack I use to charge my phone and all the other stuff. But it does have a USB-C output right here, and that gives it the capability of outputting 3.1 amps, which is perfect for the Pi because that's what it's supposed to be rated at to be working very functionally throughout time. So I have this wire going underneath. It's a pretty long wire, and it goes right to the Pi. So that was one of the major things I had to do to allow the Python programs to run smoothly and have the rover run smoothly over time. And because this is in the center now, I had to move the circuit board there. The second major thing is adding the 2 more ultrasonic sensors, one on the left, one on the right. And that's mainly because now that we have more autonomous vehicle sensors working, it will give it more options to whether to turn left or right based on if there's any obstructions in front of it or on the left or right of it. So just to go over it again, we had the center ultrasonic sensor here. You had one pulse going to the object in its way, and the time it takes for that pulse to bounce back to this eye, number 2, the time is converted into a distance, and I've told it that if there's an obstruction 30 centimeters in front of you, that you should stop and rotate left as a default. Now, since we have the 2 ultrasonic sensors on the left and right side, now I'm allowed to have the rover either turn left or right based on if there's any obstructions to the left or right of it. So for example, if we have a corner here and the rover is moving towards this corner, and there's an obstruction in front of it, and now the rover can ask, well, is there an obstruction left or right to me, and which way is the most free, which way is the most freely from obstructions? And this left sensor will check that, oh no, there's a wall here, so let's check the right side, and since the right side for this corner is free, that it will rotate right. And the same concept for the right sensor here. You have a corner. Since there's an obstruction in front of it and to the right of it, the best choice is to go left. And this is one of the ways I've been able to have this rover travel autonomously. I can put it in any type of environment. It should be able to duck and dodge different objects in its path, whether it's a wall or some boxes I made or a custom course that I made that you'll see in a future video. And it works pretty well. There's some hiccups here and there, but overall it's able to save the rover from hitting any objects in front of it. And having all 3 of them here gives you almost 180-degree field of view right here. So that's where I am with the version 2.0 and how this Ultra Instinct autonomous rover is functioning right now. Just a little summary of future plans. You do have this breadboard here that connects the sensors to the Raspberry Pi. So my next goal is to convert this into a PCB board design using Autodesk Eagle, just to learn more about PCB design. So in a future video, I'll show you, how I printed it, or how I did it with Autodesk Eagle and how I printed it, how I'm going to solder it all together. And another video, I'm going to discuss lane detection with OpenCV libraries, having the rover use some image processing techniques to follow a uh, white custom lane that I'm building. So with image processing techniques, you could follow just the white portion of a path, and the rest of it's going to be black. So it allows the rover to follow a certain a lane determined by the user. So those two things I'm working up in the future. So stick around for the playlist and other YouTube videos that I'm going to make. So here's version 2.0. It's a great start to an autonomous vehicle Rover, and I'll see you guys in the next video. Thank you.